All right, class. So there is no class, meaning we're not waking up at 7 o'clock to get to class at 7:30. I have pre-recorded this kind of early in the morning. Looks like it's 1:20 in the morning. It's cool. Who needs sleep? It's kind of overrated anyways. So let's go for it here. So 4.6, that's where we're at. We're graphing combination of functions here. Just want to tell you real quick here, this one tends to be just a little bit more um, complicated than the other sections in chapter 4 as we're sort of getting to the end of combining a lot of things together here. So combination of functions mean we can combine cosine and sine. We can combine trig functions. We can also combine linear functions as well. So let's go back real quickly here. So I got a sine function for you drawn already on the left-hand side, just to sort of see it. That's what it looks like. I think we know what those look like. Cosine function. So those should be kind of mirror imaged in your head. You should sort of remember those to be in your head. And then back from algebra, can you graph for me this guy, 1/2 x? That should be another one just to sort of graph at it. And turn off the tape if you need to here and go for it here. Otherwise, I'm going to graph this guy, and you should be able to graph it by y is equal to mx plus b. Do you guys remember that from algebra? This guy is called slope. Tells you how to move. This guy is the y-intercept, abbreviated int. And here it is. How will you do this? Looks like I better put my tick marks in here. Okay. So 1/2 x. We look at the m value. There's my m. That means I'm going to go 1 up, and I'm going to go 2 to the right, but I'm missing my b value, so that technically is 0. So my beginning value where it crosses the x-axis is at 0, 0. And all I'm going to do is I'm going to go up 1. I'm going to go 2 over. My next dot is going to be right there. I can keep on doing the same thing. I can go 1 up, 2 over, and there's my dot. And I can have my little line. Let's erase these little movements here that I've created. There it is. There's my graph. Awesome. So now let's go ahead and combine this stuff together. Let's go. Exercise 1. Can you graph for me y is equal to 1/2 x? Hey, there's that. Minus cosine x. I wonder why I gave you 1/2 x as an example. Okay, let's go for it here. And then I got to give you the domain. I want you to graph it on 0 to 4 pi. There it is. And then we have how much? 1, 2, 3, 4, 5, 6, 7. I think six graphs here, which we'll do. All right, let's jam. So first things first, we have to realize a few things. So we got to figure out our x scale. We're going to go from 0, and then we might as well do this here. We might as well just multiply 3.14 times 4, or just click the pi button and see what you get. Let me click that on my calculator over here, and I got myself about this much, right? Hopefully, again, maybe not be exactly the same, but close enough, because I want to get my range. That's what I need. Okay, so 4 times 3.14 is 12.56. That's cool. So now that's my x scale. Good. Let me go to my y scale now. Now the question is this: what number will I start with, and what number will I end with? So if I'm starting at 0, I might as well put in my little 0 into here and just see what's my x or y scale has to be. Okay, so 1/2 of 0 is 0, and cosine of 0 is 1. So technically, well, I'm starting off with -1. Okay, that's my start of my y scale. Let's see how this ends. And okay, so 12.56 is going to be, I'm going to have to use a calculator for that. I don't want to have to use a calculator. So let me kind of just go up a little bit further. So I'm thinking a good one to take half of, not 13, but maybe 14. 14 is a good one. Because remember, your y scale does not have to be as accurate, right? It could be a little bit further up, further down. So now the question is this: what is that going to give us? So half of 14 is 7, and cosine of 4 pi 0, 1, 2, 3, 4. That's going to be a 1 still. So it looks like I need at least a -1 on my y scale, and I need about a 6 on my y scale, and maybe go up. So I think I'm ready for it at least. Okay, so next slide, let's start actually putting this together here. So I'm going to put my y scale down, my x scale coming across, and at the end I should be at 4 pi because that's what I'm called to do. That's at pi, 2 pi, pi, pi over 2. Okay, so let's fill this in. So 3 pi would be about right here. Let's see, this is pi over 2, 2 pi over 2. This would be 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and then the 4 pi would be 8 pi over 2. Okay, so I got that taken care of. That's at least good. Next is my y scale. So I need to go up to 6. I'm going to go up to 7. Just give me a little bit of a cushion here. So if that's 7, so that means this would be 4, 3, 2, 1, maybe something like that. This is 1, 2, 3, 4, 5, 6. That's a good scale there. And so 1, 2. So I need to go -1, but I'm going to include one more down just to give me that -2. Okay, so what do we have? We are trying to graph this little guy. And so what I'm going to do is I'm only going to concentrate on this portion here. I'm only going to concentrate on the linear form right there. That's what I'm concentrating on. Okay, so forget the cosine just for now. Let's concentrate on this little piece. So I got to ask myself this. First of all, when I plug in the 0, I'm going to be at 0, right? So I'm going to put a little dot right here. Not a big dot, just a small dot at 0, 0. Okay, so now I'm going to scale the rest of this out. So I just need some dots to come across on. So y is equal to, I think I'm going to use pi. Pi is 3.14. That does not divide in half nicely, does it? I guess it does. Let's see. I'm thinking if it's almost at 3, you know, it's kind of close to, because in the graph we're not going to be absolutely precise either. It's kind of close to 3. I'm going to put these approximation bars like this. So about 1.5, right? So at pi, ooh, I'm going to do my little laser here. Let's see. Okay, at pi, I should be about 1.5, should be that little dot right there. Okay, so now the question is what happens at 2 pi? That's 6.28. That's 2 pi. You know, it is about 6.2. And if I take 6.2, it's going to be about 3.1, actually 3.14, right? Because I'll be pi. So I need 1, 2, 3, just a little bit above 3. There's my other one. Okay, and 3 pi. That's 12, that's 4, that's 9, 9.4. And half of 1, 9.42. So you could tell this is getting messy, right? A lot of drawing things out and a lot of computational stuff. Okay, half of that. What's half of 9.42? So half of 9 is 4, half of 14 is 7, 1. So 4.71. So at 3 pi, we're looking at 1, 2, 3, 4, and not almost close to 5, but not quite. Okay, last one, and then we'll put this together here. So 4 pi, so 3.14 times 4. Oh, we already said it's 12.56. And we're going to have to take half of that. So I'm thinking, you know, how about just close to 12.6? Let's take half of 12.6, which is 6.3. That's cool. Okay, so we got 1, 2, 3, 4, 5, 6, and about right there. Okay, I think I've got my scale. So again, we've only graphed y is equal to 1/2 x. And what I want to do is I want to graph, or chart at least, just a line like that. So this is going to be our new base. That's what this is going to be. Our new base is this piece here. Next, it's almost like we've made a new x-axis, and based upon that, we're going to work this out. So first things first is now I'm going to concentrate on the other piece of this, which is negative cosine of x. Ooh, notice the little negative there, right? That means this is an inverted cosine, and the inverted cosine looks like this. It starts off low at -1, comes up, and then comes back down by the time you get to 2 pi. All right, the important pieces here. The important piece is as 0, 0, which we've done is it moves off the x-axis by 1. It's going to be 1 lower. At pi over 2, it's exactly on the x-axis. At pi, it reaches a maximum of 1. At 3 pi over 2, it hits 0, and at 2 pi, it goes back down to your negative. So here's what we're really going to graph. We're really going to graph y is equal to 1/2 x plus a negative cosine of x. Good. So what we've done with this piece is we made a new, in a sense, x-axis. Here's our new x-axis. It's the dashed lines that are coming across. What we want to do is we want to incorporate this now into the process. So we're saying in -1, what happens with cosine? It goes lower. It goes down away from the original point, down 1. At pi over 2, so this is the easy to get, pi over 2, it's going to hit a 0 marker right here, right? So it's not going to change anything that this has done. So it's going to hit us right at the new 1/2 x marker. Now when you hit to pi, notice when you get to pi, it's actually taking whatever value it is and we're adding 1 to it. So at pi, we are at 1.57. We're going to add 1 to this and make it 2.17. That's our new dot. All right, back to here at 3 pi over 2. It's doing nothing, right? It's 0 at that point, right? So if it's at 0 at that point, we have our little dot. I should make these into a different color. Let me make, there you go, that'll be cool. So the end of my, I'll put my black dots here. So that one, that one, that one's my final graph there. And then what happens at 2 pi? 2 pi goes way back down. It's a -1 from the x-axis, right? So whatever that 1/2 x did, we're going to go down 1 from it. So let's see, right here we're at 3.14. So now we're going to go back down to 2.14. We're going to go down to this right here. Okay, now we're going to have to repeat itself, right? We've just finished one cycle. So let's see how the cycle goes. You should see a little graph that goes like this. We're just connecting the dots now. This is the top. It kind of goes down, and it kind of goes like that. See if that helps out right there. Okay, then the whole cycle repeats itself, right? Because we've just passed one cycle for cosine. Now we're going to do one more cycle. So one more cycle, here it is. At 0, we're going to go down 1 from our dot. So our dot, we didn't graph it here, but our dot is here. And what does that look like? That looks like 1, 2, 3. It looks like a little bit of a 4. A little bit of 4. So we're going to make it a little bit above 3 right here. Here's my next dot. At 3 pi, we did calculate 3 pi. 3 pi, this was at 4.71. Oh, so let's go back over here. Sorry, real quick here. Sorry, class, I messed up a little bit here. This 2 pi that we did, that is actually this little reference point right here, right? As we move on at 5 pi over 2, it's going to be this little piece right here. That's totally my fault. Sorry. So the 5 pi over 6 is acting like the pi over 2 over here. We don't move because it's technically it's a 0 there. We don't move. Nothing happens. So we don't subtract anything from the 1/2 x. So there's my little dot right there. At 3 pi, we add a 1 to that. So here, we're going to add one more. We're going to go up one more higher right there. At 3 pi over 2, which is the same thing as 7 pi over 2, again, it's going to hit our 1/2 x marker. And then at 2 pi or 4 pi, it's going to go down from our dot that we've made, and we're going to go down 1. So there is my, it's kind of moved off a little bit here. Should have moved off a little bit. Okay, so let's connect these guys. So it's going to go up like this, tops off right here, comes back down, and done. Okay, so those little connection graphs that we did, the black graphs that we did, that is it right there. That is the graph of 1/2 x plus, or 1/2 x minus cosine x. We've done it. We did the linear function first. We use that as our kind of like our base or our new x-axis that we've made. And then we shifted the cosine on its critical points. If you were to graph it in Desmos, let me bring this down. All right, if you were to graph this on Desmos, which I did earlier here, it would look like this, and very similar to what we got, right? And look at that, we're starting off at -1. We hit a high point. In fact, our high point was at pi, but looks like the high point is a little bit past pi, and that's okay. I mean, we're close. We're pretty close as far as the graph is concerned. And then we hit a low point right here, again, going up. And so it's this little wave that's progressing upwards. That's cool. We've done it. Here's our first graph. All right, so that was a linear function and a trig function here. Let's get more sophisticated. Let's go with 2. Let's go with 2 trig functions here. 2, let me see. Yep, cosine of x plus sine of 2x. Okay, 2 trig functions combined together. Let's see what's going to happen here. Again, total fun. And I think I'm going to go the same. I'm going to go from 0 to 4 pi. Okay, few things have changed from example 1. So we don't need to do the scales here as much because we have we don't have a linear function. So that's nice. That's really nice. We don't have a linear function. But we are going to have to graph both of these using dashed lines. And then we're going to combine them with a plus sign. And that's kind of how we do them. And so if you think back, how would you graph 2 cosine x? How does that work? How does it function? And again, back to the scale here. Have to have this memorized. Sine function originally goes like this. And it reaches end of itself at 2 pi. The cosine function goes like this. And it reaches the end at 2 pi. So let's go for it here. I'm going to have to use different markers here. In fact, let me change. One's going to be burgundy, the other one blue, and then our final one's going to be like a black one here. So first things first, let's go for it here. Let's scale this out. And I'm going to go like this. I am going to go to 4 pi. That's cool. erase it out. Oh yeah, much better like that. Okay. So this is going to be 2 pi. This is pi over 2. Okay, scaling this all out again. So this is 3 pi over 2, 4 pi over 2. Oh, hold on. There's a 3 pi here. That is okay. So beginning with pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. This has to be 5 pi over 2, 6 pi over 2, true, 7 pi over 2, and then eventually 8 pi over 2 would make 4 pi. Okay, so let me erase all that good stuff here. Okay, let's put some markers on our sine curve just so we know what's going to happen. And some of you guys are already anticipating. There's a few things that are going to happen. Okay, let's go for it here. So first things first, let's graph for us 2 cosine of x. That'd be something you should be able to do. We have an amplitude change of 2. And you know what? Let's give it a little bit of room. Let's go up to 4 at the most. We good? Because I'm thinking the highest this could ever reach is 2. I'm thinking the highest this could ever reach is 1. So I know I'm going to, maybe at the highest point, I might get a 3. Good. So I'm going to go just a little bit more. Let's go up to 4. So 1, 2, 3, 4. And I'm going to go down the same. So 1, 2, 3, 4. Okay, got that scale. And here it is. I'm going to graph this. So 2 cosine of x. We should have a good idea. It starts off at 2. And dashed lines, only dashed lines, because this is not the final product. It's going to go like this. And this is my cosine curve. And it goes up like this. Goes all the way back up to 2. And we start all over again. It hits 0 at 5 pi over 2. Negative 2 at 3 pi. Gets back up to 2 when we hit 4 pi. Okay, great. I have just graphed 2 cosine of x. Okay, now let me change pen color. Da, 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 da. Some blue. Let me graph sine of 2x. Now we got ourselves a little problem. Don't we have a period change, huh? So for sine of 2x, the period's going to be 2 pi divided by 2, which will just be pi. So everything is happening twice as fast. Okay, for me, that's a little problem. Because now, instead of having a scales of pi over 2, I have to have scales of pi over 4. So here's my pi over 4. So that's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4, 14 pi over 4, 15 pi over 4. Okay. Ooh, that changed my scale. Okay. On the sine curve, what happened? Everything is happening twice as fast. So in my mind, now I'm thinking this for the sine curve. It's going up, going back down, and done by the time it gets to pi. So this is pi over 2. My critical points happen at pi over 4. 3 pi over 4 as well as 0. Okay, so when it hits pi over 4, we're going to get a maximum out of sine. When it hits pi over 2, we're going to hit a 0 again. 3 pi over 4, it's going to hit a minimum of -1 and back up to 0 when you hit pi. Let's start. So I'm thinking it's going to go like this. Maximum value of 1 here. Back down to 0. To -1 down here right at 3 pi over 4. And back up to 0. I think I'm going to do these blue dots a little bit bigger. Okay, and then there it is. There's my first round. I'm going to have to do 4 cycles of this. So up to 1 to 0, -1, 0. Up to 1, 0, -1, 0. Up to 1, 0, -1. And back to 0. Okay. There's my dots. Let me graph this. Again, an edged graph. This is not the final graph that we have. This is just a sketch, but it gives us the sine curve. Okay. Boom. Whew. All right. Let's change to darkest color I can get. Okay, that's pretty good thickness there. So here's what we need to do. We're going to combine this together with a plus sign. What I mean by plus sign is if you see both of them being 0, you know that 0 plus 0 is 0. If you see one that's at 0, but the other one is at another form, we're going to click that dot. So let's kind of see how this works here. So let me see if I can zoom in here. Yeah, that's cool. I can zoom in. So on the first one, notice sine is 0, but cosine is at 2. So I know for sure that if I add these guys together, because sine is at 0, cosine is at 2, then that dot is going to be at 0. So now let's do another one here. Let's see. This guy's at 1, and this guy's a little bit above 1, right? So right here at the scale here, we're going to kind of add an extra 1. So it should be about right there. Now notice at pi over 2, both of them become 0. So 0 plus 0 would just be 0. So there's my little dot there. And let's come across. Let's see what we have here. Okay. So now this scale here. So I have a -1 here, and then I have some more here. So I'm going to take this guy. Looks like it's almost at -2, not quite at -2. So I'm going to move this dot all the way to here. It's kind of like almost at -2 plus we're subtracting an extra 1. Oh, this is good. Notice the blue graph is at 0. The original burgundy graph is here, so it has to be here because 0 plus -2 will still be -2. Okay, and then comes the tricky one. At 5 pi over 4, we gotta have to think about this here. So notice this is at 1, and this is coming off of, let's see, it's less than 2. So notice it's a bigger negative here than a positive. So I'm going to put this guy about right there. Okay, let's keep on scaling out here. Oh, look at that. They both cross at 0, 0 at 3 pi over 2. That's a nice graph right there. Again, notice the big disparity in the positive values, small disparity in the negative values. You know it's at least positive. This guy's at 0 here, so it's adding nothing to it. So I know this is going to be a graph there. Ooh, again, here's that 1 marker, a little bit beyond 1. So I'm going to go this way up. So I'm going to add an extra 1 from this little dot right there. Okay, back down to 0. This is at -1. This is almost at -2, but not quite. So again, this is going to go down even further like that. At 3 pi, it's right at there. It's more negative than positive, so it's going to be about right there. Again, both cross at 0 at 7 pi over 2. Let's bring the scales over. Again, more positive than negative, so about right there. And we got our 0 marker for the blue graph, 2 for my burgundy graph, so there it is. Okay, let's scale this back now. Whew. Okay, I think we got it. Let's see what happens here. We're starting off at 2. It goes up high like this because the addition of these guys together, added apart, it gives you this. And then we're going to go straight down real quick here. We're going to go vroom. So still make it curved. It's going to come back down to all the way down here. And then it curves back up. So the curve is this way. Seems like the curve is going to change direction just a little bit here because the way There's a bit of a long stretch between 5 pi over 4 and 3 pi over 2. Okay, so then we wrap it up again. Turns like this, looks like, and then we got to start turning the other way because we need to go down to 0 again. 0 comes. There's a low marker, comes back up like this. So, and then I got to turn. It seems like it has to turn this way, and then it curves up. And then, you know, by the time it hits here, we got to turn it around because it's going to go starting to go back down to 0. So maybe kind of like that. All right. Oof. I lost sight of where my 2 value is. That's the problem. There it is. That's a better curve there. Okay. And I lost sight of where my, notice. Okay, so real quick here, this should have been a little bit further down because I don't have graph paper on mine. That's the problem. So if you have graph paper, please use graph paper. That would be really good to use graph paper so you can make these a little bit more. Okay, so let me switch screens here. This is what I have after graphing it on Desmos. Right there, and our graph kind of looks the same, yeah. Notice we hit a high point right here. Looks like this is pi over 2, this is pi over 4. So our high point was at pi over 4, but looks like the high point is a little bit before pi over 4. Again, that's okay. We hit our zeros, and then we kind of made this little graph up like this. Okay. Oh, that's right. Yeah, at 4 pi, it's really not quite getting to. Right, it still needs to go a little higher, right? Because notice the scale over here, it hits a high point after the 0 marker. So it was still actually climbing. It was still climbing before we make the turn. Okay, there it is. There is the trig function here, added with another trig function here. So let's, I'm gonna let you guys try yourself. Got a couple of things here. Let's do a couple ones yourself here. Okay, so trig function with trig function here. Exercise 3. Can you graph for me? I'm going to find out. All right, I think this will be a good one here. So sine of x plus sine 2x. Hey, that'll be good, especially considering what we just did before. Okay, if you think you got it, try it yourself. Go and pause the video. Try it yourself. See if you got it. I'm going to start in just a second. All right, got myself some graph paper as well. Oh, I didn't tell you about let's see from where to where. So we're going to go from 0 to 2 pi. I grabbed some graph paper off the internet so I can do this a little bit better. And so we're going from 0 to 2 pi. That's perfect. Okay, so can you graph the sine of x first? And then graph it again, a burgundy color here. Once you do that, can you graph the other one and see if you can combine them? And so off to the side again, go back to your previous notes and see what the graph of sine of x is. If you know it, go ahead and graph it. I'm going to start it. I'm going to start off 0, 0. That's when it starts. Hits a high point at pi over 2. Hits a 0 at pi. Hits a low point at 3 pi over 2 and back to 0. So here's my sine curve stretching out. There it is. Okay, there's that one. Then, so that one was sine of x. Now we're going to graph sine of 2x. Again, we graphed it already. Off to the side. We know what's going to happen now. So by the time it reaches pi, it's going to do all it needs to do. It's just a faster, it goes twice as fast. So it's going to do all of that before it hits pi. So high point is at pi over 4, hits 0 at pi over 2, hits a low point at 3 pi over 4, and back up to 0 once it hits pi. So let's do that here. So 0, 0. The high point comes at pi over 4. The 0 comes at pi over 2. The negative 1 at 3 pi over 2, and then hit 0 right there. And again, a repeat here. Boom, 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 boom. Okay, I'm going to graph this here. So it goes up like this. Goes down. Back up. And down. And up. There it is. I think I got what I need out of it here with nice graph paper now. Okay, let's jam. So we're adding things together. Okay, so I'm going to go to black marker so you guys can see it better here. So first things first, I notice at 0, 0, I can keep that guy because 0 plus 0 is still 0. I also notice some other zeros here. So right at pi, notice we're going to hit a 0 right at pi. And then at 2 pi, they both converge to 0 at 2 pi. So those 3 dots I have perfectly made. Next, what's the next other dots? Anytime the other graph is at 0, you know that 0 plus whatever else is going to be that whatever else. So notice at pi over 2, the blue graph is at 0, the burgundy graph is at 1. So I know for sure, I'm going to hit 1 there. Any other time they're going to hit a 0. Yeah, at 3 pi over 2 and negative 1. So I know those guys are built in right there. Perfect. Okay, now we're up to the other stuff. Okay, so we're going to, the burgundy graph is a little bit less than 1 right here, and the blue graph is right at 1. So what we're going to do is we're going to try to add these guys up. So we're going to say that, okay, so that's 1. That's what, about maybe like 0.7-ish or something like that. So I'm going to move this up to be about right there. It's going to be the addition of those two together. On this one, I notice the up one is at maybe like 0.7-ish, but this one's all the way down at negative 1. So I'm thinking it might have went under. Let's see. Yeah, so notice on this one here, it's less than 1 here, but then it's definitely 1 here. So that means maybe like somewhere right here. So then we're looking for a little gap of space that's, I think about right here, maybe it went under. So notice the positive side and the negative side are about equal. That's what I'm looking for as well. So that's pi. Let's see some other stuff here. So after pi, notice what happens here. The blue graph goes up really quick to 1, right? The burgundy graph is very slow to get to negative 1. Very slow. So that means that the positive side is going to really take off here. So it's going to go higher like this. And so it seems like it goes up, but notice the blue graph, it goes up to 1, and it's less than negative 1 right here. So you know it's going to be positive, somewhere positive here. But then sometime when the blue graph is coming down and the burgundy graph is still trying to get to negative 1, there's going to be a time where it's going to go through 0 again. It's against the difference between the negatives and the positives. Then it goes down to here. And again, we have the scenario as at 7 pi over 4. It's at 1. It's a negative 1. And the other one's almost at negative 1. So it's going to go way down here. And then eventually we still got to get to 0. So let's try this. I'm going to connect my black dots together. Let's see what happens. So going up. And I'm not sure if this is the maximum. So I'm going to kind of just scale it down. This one, it goes through here. It goes here, turns. It gets a little bit positive, then it has to turn back around to get to negative. Then it goes all the way down here, and then it turns back around like that. Whew, okay. That is it. It looks pretty interesting. So let's let me share what I have as I did it, as I graphed it on Desmos here. My new share. So there it is. And yes, so we went just from 0 to 2 pi, but it went like this right here. Boom. There's our little dots there. There's a 0 marker right here. It went up a little bit above. So I'm going to go 0, 0, start off yes. At pi over 4, actually it reaches almost the maximum. This is pi over 4 right here. And at pi over 2, it's still positive. And then somewhere between pi over 2 and 3 pi over 4, it hits a 0 marker. It goes a little bit lower. And then it hits 0 at pi, again goes up, then hits 0 sometime afterwards, hits a low point, and then back up to 0 at 2 pi. Okay, that is how we graph these. That's what it looks like. All right, let's try another one here. And this would be, I think this would be the last one here. Oh, can't show you the answer yet. So let me change the share button back to here. I'm going to go with exercise, I think it's 4, correct? 4. Oh, this would be a good one. This is going to be, can you graph for me cosine of x plus sine of x? Those would be 2 good ones to graph. All yours, have fun. Maybe second to, yeah, this is second to last. We're going to do another linear function at the end. So again, pause the video if you think you got it. And then we'll go from there. And I'll join you in just a bit. And again, I forgot to tell you which domain you need to concentrate on. So there it is. All right, let's go for it. This one you should be able to do by yourself. You should be able to know how to graph cosine. So let's do that one first. Cosine starts off at 1, hits the 0 marker at pi over 2, hits the -1 marker at pi, 3 pi over 2 back up to 0, and hits 1 at 2 pi. There it is. There's my little dots there. And again, the little dashed lines to connect them. Okay, let's go with it. Now let's go with the sine curve in blue. Sine curve starts off at 0, 0, hits 1 at 2 pi, back down to 0, down to -1 and 2 pi. So here it is, my sine curve. Okay, if you got this, this is great. If you can do that and put this all together, doing great. Let me change mine to the black marker again, and let's go with it. So graphing this out, again, we're looking for any, notice there's never a time where both of them are 0, 0. They're both hitting the x-axis. That's a bummer. Okay, that's okay. We can still work with it. Let's see what numbers we can get. So right at the beginning, one's at 0, one's at 1. So therefore, you know that you're going to have to hit the top there. Now, let's see, when they cross, they're both like that. So I'm thinking it's going to go higher than 1. So at least I'm going to put that guy there. I'm not sure if that's the maximum or not. This one definitely is going to hit the blue marker because the other one's at 0. So then they start going down, down, and notice sometime here, sometime during this process, the stuff above the x-axis and the stuff below the x-axis is going to be exactly the same. So that's when it's going to hit across the x-axis. It has to. And then at pi, it's going to hit a -1 because the other one's at 0. It's going to go even further in. So what's that? Maybe like, it hits actually a little bit after 3 pi over 4 when it combines together. So I'm just going to put it like somewhere about right here. Okay, 3 pi over 2. The other one's 0. The other one's at -1, so -1 wins. And again, here we go again. Sometime during this process, and you kind of just have to scale it. So kind of as you think about it, where does it look like above the x-axis and below the x-axis exactly the same? I'm thinking like right about here, a little bit above 7 pi over 4. And then we have this one here, right at 1. Okay, I think I got my graph. Let's go with it here. Starts off here, goes like this, hits the 0, turns back around, and I'm looking for something looks like this. Okay, and then you know it's going to go further up, right? You know, it's because it hits this little, the high point is still going, right? And it's still going up higher and higher and higher, but at least that's the marker for it. Okay, let's look at my little graph screen on Desmos right there, and our graph looks, yeah, pretty good. We start off at 1, went a little higher, and before it hit pi, we had to go under, and then we hit -1 at pi, and then it still went a little further, and then before it hit 2 pi, some long time along the road, it's going to hit 0 marker, and again, it's still going to go up. So we only graphed it up to 2 pi. Okay, so now let's go back to that little linear form. This will be the last graph here. So graph for me. Oh yeah, that's right. This will be x plus cosine of pi x. Okay, so this is where things get interesting with mathematics. And let's go from 0 to 5. We're going to go 0 to 5. Okay. So yeah, I have this little pi times x inside cosine. So that's very interesting. If we do that, think about this little pi inside here, right? So for the period, for cosine would be 2 pi divided by 2, which is just, 2 pi divided by pi, which is that little piece right there. That's what we're getting at. That's just going to be 2. So forget about pi altogether. This is just going to be real numbers with real numbers, just going at it. That's awesome. Okay. So now let's see how this should work out. So start again, like we did before. Start would be 0 plus cosine of 0, which will just be 0 plus 1 or is 1. The end value. End value would be 5 plus cosine of 5 pi. Interesting. So 5 pi, that's a -1, right? Because that's the other side. So that's a -1. So 4. Okay, just to keep my scale up, though, I think I'm going to leave 5, maybe even go up to 6, just so I have a little bit of a buffer there. So let's go with it here. So I got this. I know it's going to be climbing. So I got myself 1, 2, 3, 4, 5, 6. I got a 1, 2, 3, 4, 5, 6, somewhere in that range, about right there. Okay, but I'm going to only go up to 5, so let me erase the last one here. Okay, so first things first is let's graph y is equal to x. That one we should know how to graph. This is a graph that goes 0, 0. It'll go 1, 1. It'll go 2, 2, 3, 3, 4, 4, 5, 5. Again, if you have graph paper, way better with graph paper. It looks like my Y scale is just a little bit off. Again, general idea. Okay, let's talk about the cosine here. So we said that the period for cosine will be 2. It's not flipped or anything. So it's going to start off high. And by the time it's all done, it has to be 2. So that means at the 1 marker, it's going to be low. At the 1/2 marker, it's going to be that. And at the 1.5 marker, it's going to be 0. So there's my graph for cosine. So let me make sense of it over here. I have to put in the tick marks then. So that's 1, 2, 3, 4, 5. So in order to make this make sense here, I'm going to have to put my little half tick marks into this little scale. I think we're almost done. Well, I used black initially, so I guess I better change my color for the final one. Okay. So when we start off at 0, 0, cosine is already at 1. So I'm going to plot that point in already here. There's my, and let me zoom in now. Okay, at the half marker, cosine is not adding anything because it's 0. So at the half marker, it's just going to be on my little line x is equal to y. At 1, we're going to go down. Oh, interesting. Look at this. At 1, this graph is at 1, 1 originally, right? So we're going to actually have to go back down to 0 because cosine is going to bring it down by 1. Okay, the next marker at pi over 2, it's going to go back up to this little graph right here. So I should erase the little blue thingamajiggy. There it is. So that's my little graph there. At 2, it's back up to 1, right? So it's 1 higher than the graph itself. So it's actually, if it's a 1, it's going to go up to 3. So there's my graph of this guy here. It goes like this, goes like that, and it starts climbing up like that. I'm not sure. Maybe don't want to draw this yet because I'm not sure if it curves yet or if it starts shooting up even more. So I'm going to leave those dots available here. Okay, so we're going to repeat this process of 1, 0, -1 here. So at 2.5, it's going to go back to 2.5 right here. My 3 scale was off a little bit here now that I see my 3 scale being better. Yeah, 3, it's going to go 1 below the marker, so it's going to be here. At 3.5, it's going to shoot up to be right at the line itself, and at 4, it's going to hop up to 5. It's a little bit higher. So I'm going to put it about right there. Okay, I completed another cycle. So now I'm going to go down. At 4.5, it's going to hit my little line again. And at 5, it's going to droop down to 4 again. So it droops down like this. Okay, I think I got it. Let's see. So based upon all that I can see, it's going to go up like this. And at 2, it's going to go up like this. Seems like there's a little high point right here. Then I have to come back down. Then it hits another high point. It comes back down. So there it is. And love it. That's cool. Okay. Let's look at the Desmos graph of it. Here's what I got. Mine goes out to 10, but that's fine. We're only going up to 5 here. So yeah, notice the drop. In fact, Desmos says it actually goes below 0 right here and then it comes back up. So there's a little 0 here, 0 here. Again, we're just trying to get a rough estimation of this graph. At 2.5, at 2, it actually peaks right here, just like we had in our graph. Goes back down. And then it, again, hits a low point at 3. And then comes back up. And then, again, hits a little low point as it's climbing up. Okay, there it is. We have combined together linear and trig functions together. We've combined multiple trig functions together as well. And one nifty graph I wanted to show you is application of trig functions here. Engineering in wavelengths of forms, and in physics here. We have a mathematician by the name of Joseph Fourier. There you go. That's how you say his name. French mathematician. Was an orphan. Then went to the a bishop picked him up and educated him in a convent. And he grew up sort of learning things that were in the convent, because it was a storehouse of a lot of classical literature there. Couldn't go further than that because he was not from stock. So he accepted military lecturership and served in the army and all the good stuff here. But eventually he was a mathematician. He was a mathematician, and he did some things. He did some greenhouse effect things here. He started looking at how, not so much electricity, but maybe how conduction works. And he was kind of the forerunner to conduction. So here's kind of just a fun little graph of his. Here it is. As Fourier series. Eventually, it was just a fun math thing back then, and then it, after a while, as we know this to be magnetism is part of this whole concept of, because magnetism has electrical energy in it. Electricity is part of this. Whole globs of engineering has a lot of things that has these series involved in it. So I thought that was kind of cool in it. Anyways, that's a fun little graph. How about that? You guys want to graph that one? That'll be a little twisted graph. Anyways, hopefully you guys got this. Please try the homework. And next time I see you, we'll go over any homework you guys have, and enjoy the rest of your day.